So we are going to talk now about state transition systems. And what is a state transition system? Informally, it is consisting of a set of states and a rule that governs from which state how you move to the next state, which we call sometimes a binary. It's a binary relation between states, but sometimes if you can only move from one state to another state, to single state, then it is also a function. So sometimes we call it a transition function. And we have a set of initial state where you start the whole thing. So let us look here. So sequential programs are actually can be described by a state transition system where you move from one state to another in a deterministic way. Okay. So there is only one way to move. In fact, if we look to this little program here, we can describe it as a state transition system. We do it actually by drawing the graph corresponding to the state transition system. So initially, we are at this state. This is the state where x equals 0. If we pass through this test and we execute this statement, we move to a state at this point where x equal to 1. We do the loop one more time, and the condition is still holding, and we move to a state at this point again. Also, it is this point where x equal to 2. And then we execute this statement, and we are in a final state where x equal to 1. So as you can see here, we have these 4 states described here. We have the transition function in this case described by the arrows that in the diagram, and we have the initial state is S0. So if we look to distributed algorithm, just as a contrast, sequential algorithm can be modeled as a function from input to output. So we don't really need to model them as state transition system, but many actually do. There is some semantics for describing sequential programs as a state transition system. But when we move to distributed systems and distributed algorithms, so these are systems that run forever and interact with the environment. So the most common way to describe this is by modeling it as a transition system. Okay. So let us go through the formal definition of a transition system. So a transition system is a triple consisting of a set of states, a binary relation, which is called the transition relation, and a set of initial states, which is a subset of the set of all states. So if we look to the transition relation, so it is a subset of S Cartesian product with itself, and it just tells you, so each element in this transition relation is a tuple from initial state and a final state. It just tells you from S1 I can move to S2, and it's written like this. And an execution of a transition system is a sequence of states starting from the initial state is, this will be a state part of the set I, and you move from one state to the next if there is such an element in the transition relation. So you move from S1 to S2, S1 to S2 must be part of the transition relation. This is part of that transition relation. what is a terminal state? Is a state where you are stuck there, you cannot move. So a state SF for which there is no state X such that there is no such element in the transition relation, then that is a final state. What is a maximal sequence? This is an execution, as you can see here, is a maximal sequence if it is infinite or ends in a terminal state. And then we have the intuitive notion of what it means for a state to be reachable from another state. And that will happen if there is a sequence where the initial state here is X and the final state is Y, and all of these movements are legal movement according to transition relation. That's it. And we say that Y is reachable if it is reachable from any initial state. That gives a definition of transition system. But what we are going to cover and use is actually what we call label transition system. Now that you know what's a transition system, label transition system is quite simple. It's just telling you if I'm in state Si and I'm going to move to another state Si plus 1, I'll do that by performing an action A. That's what this says, performing an action A. So a labeled transition system, so it is labeled, is a 4-tuple set of initial state, set of actions, the transition relation, and the set of initial states. We know what is S. A is a set of actions, and this is a transition relation which takes a state, an action, and moves to a next state. We know what's I. So again, a transition relation will be a subset of S times A times S, and here is how you can write it. Sometimes it is written like this. You are at state S1, you perform an action A, and you move to S2. The rest is as before. So the most important aspect of label transition system is that execution now interleaves states and actions. States and actions. So we have state followed by an action, state followed by an action, and then state, and so on.